Look up. Right now, tonight, the moon is up there. Maybe you can see it. Maybe it's hiding behind clouds, but it's there. It's always been there. It's been there for 4.5 billion years. Now imagine you look up and it's gone. Not dimmed, not faded, gone. The sky where the moon used to be is just black. Most people's first reaction would be confusion, then maybe curiosity. That's weird. And then, in the days and weeks and years that follow, everything they take for granted about living on this planet, the seasons, the oceans, the length of a day, the stability of the climate, the existence of complex life itself, would start to unravel. Because the moon isn't just a light in the sky, it's a gravitational anchor, a tidal engine, a planetary stabilizer that's been quietly running in the background of every single day of Earth's history. And we have no idea how much we depend on it until it's gone. This is what actually happens, second by second, day by day, and then thousand by thousand years. Before we watch it disappear, we need to understand what we're actually losing. The moon is not small. It's the 5th largest moon in the entire solar system, and relative to its planet, it's the largest. No other planet has a moon this proportionally massive compared to itself. Earth and moon are almost a double planet system, and it got here in the most violent way possible. 4.5 billion years ago, the young Earth was hit by a Mars-sized object. Scientists call it Theia. The collision was so catastrophic that it melted the entire surface of the Earth, blasted a massive chunk of material into orbit, and from that debris, over thousands of years, the moon coalesced. From the very beginning, Earth and moon have been locked together, gravitationally, tidally, climatically. They formed together. They evolved together. And for 4.5 billion years, they've been inseparable. The moon is slowly moving away from us, about 3.8 centimeters per year, roughly the rate your fingernails grow. In the distant past, it was much closer. The tides were enormous. Days were shorter. The early ocean was constantly churning. And here's the thing most people don't know. Life, complex, multicellular, eventually human life, may have only been possible because of that churning. The moon didn't just illuminate the night. It may have built the conditions for us to exist. So what happens the moment it's gone? The moment the moon disappears, nothing dramatic happens on Earth. No explosion, no shockwave, no earthquake. The sky gets darker, significantly darker. The moon reflects about 12% of the sunlight that hits it, and on a full moon night, it's bright enough to cast shadows. Without it, even a cloudless night becomes far darker than most people alive today have ever experienced. Wildlife notices immediately. Hundreds of species, sea turtles, moths, migratory birds, fireflies, dung beetles, navigate by moonlight. In the first seconds and minutes after the moon disappears, The nocturnal world goes into disarray. But here's what doesn't happen, at least not yet. The tides don't stop instantly. The ocean has momentum. The water that's already been pulled keeps moving for a while. And the Earth's axial tilt, 23.5 degrees, the thing that gives us our seasons, stays exactly where it is. For now. Because these effects, the big ones, the civilization-ending ones, don't happen in seconds. They happen slowly, which in some ways is worse. Within the first 24 hours, the tides begin to change. Right now, the moon is responsible for about 2/3 of the tidal force on Earth. The sun handles the rest. Without the moon, tides don't disappear. They shrink to roughly 1/3 of their current height. The dramatic rise and fall of coastal waters that you see in places like the Bay of Fundy, where tides can swing 50 feet, becomes a gentle, nearly imperceptible ripple. On the surface, this might sound manageable. Less flooding, more stable coastlines, easier navigation. But ecosystems don't see it that way. Intertidal zones, the strips of coastline between high and low tide, are some of the most productive ecosystems on the planet. Crabs, mussels, barnacles, starfish, sea anemones, hundreds of species of shorebirds, they all depend on the rhythmic exposure and flooding that tides provide. Without strong tides, these zones collapse almost immediately. The ripple effect moves into the ocean itself. Tides drive deep ocean circulation. They pull cold, nutrient-rich water from the depths up toward the surface, feeding the base of the marine food chain. Without tidal mixing, the deep ocean and the surface ocean start to stratify. Nutrients stop circulating. Phytoplankton, which produces roughly half of Earth's oxygen, begins to decline. We're not in crisis yet, but the foundation is cracking. A month in, and the most obvious change isn't geological or climatic. It's psychological. Humans have organized time around the moon for the entirety of recorded history. The word month literally comes from moon. The Islamic calendar is entirely lunar. Hindu festivals, Jewish holidays, Easter, all governed by the moon cycle. For thousands of years, farmers planted by lunar calendars. Sailors navigated by it. Lovers met under it. All of that is gone. The sky on a clear night is now spectacular. More stars visible than anyone in a modern city has ever seen. But it's also deeply, unsettlingly empty. Something that has been in that sky for longer than the human species has existed is simply no longer there. Meanwhile, animals that time their reproduction to the lunar cycle begin to desynchronize. Coral reefs, which coordinate mass spawning events based on the full moon, miss their cues. Certain fish species that rely on moonlit nights to spawn or avoid spawning during them are thrown into chaos. The ocean ecosystem is beginning to fragment. But what's coming over the next months and years is far more serious than any of this. Here's the thing that almost no one talks about when they imagine the moon disappearing. It's not the tides. It's not the dark nights. It's not even the loss of the calendar. It's this. The moon stabilizes the tilt of Earth's axis. Right now, Earth is tilted at 23.5 degrees. That tilt is what gives us seasons. The northern hemisphere leans toward the sun in summer and away from it in winter. It's been remarkably stable for millions of years, fluctuating only slightly between about 22 and 24.5 degrees over 41,000-year cycles. The moon is the reason for that stability. Its gravity acts like a gyroscope, dampening the chaotic forces that the other planets, primarily Jupiter and Saturn, are constantly exerting on Earth's orientation. Without the moon, that gyroscope is gone. Researchers have modeled what happens to Earth's axial tilt without lunar stabilization, and the results are extraordinary. Over tens of thousands of years, the tilt could oscillate wildly, swinging from near 0 degrees to more than 85 degrees. Let's think about what that actually means. At 0 degrees of tilt, there are no seasons. The equator bakes continuously. The poles receive weak, eternal twilight. Rainfall patterns collapse. The vast majority of agriculture, which depends on seasonal cycles, fails. At 85 degrees of tilt, Earth is nearly lying on its side. The poles would spend 6 months in continuous sunlight and 6 months in total darkness. Temperatures at the poles would swing by hundreds of degrees between seasons. Ice ages and periods of extreme heat would follow each other in rapid succession. The climate system, already fragile, would be operating in a regime that life on Earth has never experienced. And the transition isn't slow and gentle. It's chaotic, unpredictable. One region might experience 3 consecutive brutal winters, then a decade of near-desert heat, then a short cold snap followed by flooding unlike anything in recorded history. Agriculture, and with it human civilization, cannot plan for a climate that behaves this way. Here's a question that scientists genuinely argue about. Could complex life have evolved on Earth at all without the moon? We know that simple microbial life is almost impossible to stop. Bacteria thrive in conditions far more extreme than anything a moonless Earth could produce. The early moon-free Earth would still have liquid water. It would still have an atmosphere. Life would probably still begin. But then what? The moon may have played a direct role in the acceleration of evolution. The strong tides of the early moon, when the moon was much closer, created intertidal zones of tremendous complexity and dynamism. Life was forced to adapt to regular flooding, drying, and extreme conditions. Some researchers believe this is where the first complex multicellular organisms learned to survive out of water. where the first lungs developed, where the first land animals took their first steps. Without the moon, those tidal zones would have been far quieter, far less demanding. And some scientists argue that life, finding less pressure to adapt, might have stayed in the ocean indefinitely. There's another issue: the length of a day. Without the moon's tidal braking, Earth's rotation would never have slowed down from its primordial 6-hour spin. A moonless Earth today might have days lasting 8 hours. Some researchers believe that longer days, more continuous sunlight, were essential to the explosion of photosynthesis that pumped oxygen into the atmosphere and made complex animal life possible. We can't be certain, but the moon's fingerprints are on the entire history of complex life on this planet. A 1,000 years without the moon. By this point, the axial tilt has begun its first major wobble. Seasons in the northern hemisphere are no longer predictable. Some years, summer barely comes. Others, winter refuses to end. Monsoon systems, which billions of people depend on for fresh water, have shifted geographically. Regions that were fertile for 10,000 years are now desert. Deserts that were stable have become seasonally flooded wastelands. Human civilization is extraordinarily adaptable. But this is the speed of change that civilizations fall at, not adapt to. Agriculture hasn't vanished, but it's been pushed toward the equator, where the worst of the axial instability hasn't yet arrived. Coastal populations have largely moved inland, as the disrupted ocean circulation and changing sea levels have made coastlines unreliable. Nighttime has been permanently transformed. Generations of humans have grown up never seeing the moon. The psychological imprint is hard to quantify, but the moon appears in more human mythology, religion, art, and literature than almost any other object in existence. Its absence is a wound that cultures carry. The ocean ecosystem is in serious trouble. Deep ocean circulation has slowed dramatically without tidal forcing. Dead zones, areas of low oxygen where almost nothing can live, have expanded. Commercial fishing has collapsed in most regions, and the worst hasn't happened yet. On the timescale of tens of thousands of years, the axial tilt is now doing something Earth has never experienced in the age of complex life. It's oscillating violently. Imagine a planet where the poles spend 6 months facing the sun at a nearly perpendicular angle, absorbing heat continuously, melting ice, raising sea levels, flooding vast coastal regions that were rebuilt after the first 1,000 years of migration. Then, the tilt swings the other way, and those same poles plunge into months of absolute darkness. Temperatures plummet by 100 degrees in a matter of months. Oceans that were warming and expanding now freeze in patches. Weather systems that have never existed on Earth begin to form. The biosphere, which adapted over millions of years to a stable Earth, cannot keep pace. Mass extinctions have happened before. The asteroid that killed the dinosaurs. The Permian extinction that wiped out 96% of all species. Those were sudden catastrophes. This is a drawn-out, relentless, never-ending series of catastrophes that never allow recovery. Complex ecosystems collapse. Forests that depend on predictable seasons die back. Then, when the tilt swings back, they try to recover, but the soil is gone. The seed banks are depleted. The insects that once pollinated them are extinct. Human civilization, if it still exists in any recognizable form, has retreated to small, intensely managed enclaves near the equator. This is not an apocalypse in a day. It's a slow dismemberment of everything that made Earth livable for complex life. Our planet is not naturally stable. It's stable because 4.5 billion years ago, a rock the size of Mars hit us at just the right angle, and the debris that scattered into orbit slowly assembled into the perfect gravitational partner. That was an accident. A cosmic accident so improbable that some scientists believe it's one of the reasons we don't detect more complex civilizations in the universe. Other planets might not have gotten so lucky. We did. And we spend almost no time thinking about it. Tonight, if it's clear, you can go outside and look up and see the moon. And maybe now, for the first time, you won't just see a light in the sky. You'll see the reason the seasons make sense. The reason the oceans breathe. The reason a day is 24 hours long and not 8. The reason that the first creatures to drag themselves out of the ocean billions of years ago survived long enough to eventually become us. There's a line from the astronaut Michael Collins, the third member of Apollo 11, the one who stayed in orbit while Armstrong and Aldrin walked on the surface. He said that from where he orbited, he could cover the entire Earth with his thumb. Everything humanity had ever built, every war, every love story, every city, every harvest, covered by a thumb. The moon is only a little further away, and it holds up everything that thumb was hiding. If this video changed the way you look at the sky tonight, subscribe, because we're just getting started.